Hello, my name is Garcia, and the algae I was chosen, or I was picked, was the Halophila. So the taxonomy for this I found through the green algae lab manual was that empire is Eukaryotta, kingdom is Panthea, phylum is Trichophyta, class is Monocots, order is Halophila, family is Hydrocaractacea, and the genus is the Halophila. And then according to the sys.com, or algaebase.org, I found that there was a list of 23 species for this for the genus, and so I chose 3 to talk about today, which is Hawaiiana, Nipoconia, and Stipulacea. So first with the Hawaiiana, according to Michelle Taxis, she says that the algae is indigenous to Hawaii, so it's found here in Hawaii, and it has a relatively really fast growth rate. It also contains vascular tissue. And then she also notes that some of the features from this algae is that it doesn't really do well with sediment that's kind of like that stays by itself. So she points out that with this algae, she noticed that in areas where there's a really rapid sediment increase, or there's an increase in sediment, the algae also grows fast to accommodate with that. She also pointed out that it's found in the intertidal zone to about 10 meters depth. So if you go snorkeling, you can definitely see it, all around, and that's what it looks like. And then, as interesting research, according to Unabia, she did a research based on the relationship between the endemic sea snail with this algae. The sea snail is called the Smaragdia boreani. And so specifically what she did was she was researching the way how that sea snail basically eats and interacts with the seagrass. So she concluded that when the sea snail eats using the radula, that the teeth, it marks up the algae, and a protoplast that's found within the algae is kind of left on the outside of the radula, and that's how the sea snail it gets most of its nutrients from. She also noted that the sea snail prefers to eat the algae in areas where it's less filamenty and has really thin cell. So that's right about like this area, right around there. The second algae I chose was, it was Nipoconia. And so this one, it typically is found in the tropical and subtropical areas. But on a research by Kim and his group, he found that he specifically targeted Japanese waters and Korean waters. So in 2007 or 2006, they found that this species had entered into the Japanese waters, so right around over here. And then in 2007, a year later, they found that it started entering into the the Korean water. So they say that might be from the Kushio Current. And so, specifically with this research, they tried to figure out the evolutionary lineage for this algae. And so they concluded that they used the ITS genetic sequencing to help figure out the evolutionary traits of it. So they found that this algae is kind of related to other ones called Halophila ovalis and 2 other algae. And then the last algae I chose is Stipulacea, which is found in the Caribbean seas, and so it's actually an invasive algae there. It replaces a lot of the native native seagrass that grows there. However, on a weird note, this research kind of talks about, I guess, the good effects that comes out from this algae. They found that even though this does replace a lot of the native seagrass there, that it produces a lot of habitat space. Or they noticed that in the areas where it grows, a lot of life tends to be found with it, as opposed to the native seagrass. And so some of the animals that they found, it's all within these areas, where the sponges, brittle stars, bivalves, sea urchins, long spine porcupine fish, and then the gold spotted eel.